Okay, so I'm going to quickly go through and prove what quotient rule is, but I'm going to show you what the quotient rule is so that you can see where we're going when we work our way towards it. So if I have a function q that is a high function over a low function, that's why I use h for high and L for low, because the low one is in the bottom. The derivative of that is the low function times the derivative of the high one minus the high times the derivative of the low all over the low squared. So we have a way to remember that. So you can see right there in red, I say low d high minus high d low over low low. So the low is the L there. The d means take the derivative, so take the derivative of the high minus high d low over low low. So the low low is just, I think it's easy. Some people say low squared, but I feel like low low is easier to remember when you're trying to do this. So I'm going to go ahead and prove it to you. So I'm going to start in blue. I'm going to let Q equal H over L, just like I have up here. I know product rule at this point, so what I can do is multiply by L on both sides and get the, L times Q equals H. And at this point, sorry I got distracted there for a moment, so let me start over. So I've got the low here and the quotient here and the high here, that's an H. There we go, better. And I want to figure out what Q prime equals. That's my goal. So I know product rule. And what I can do is, when I have it in this form, find the derivative of this equation, and then I'm going to get a Q prime in there, because at some point I'm going to derive this, and I'm going to solve for that, and that's going to give me what Q prime is. So to do this, I do the derivative of the first. I'm going to do product rule on this side. So I do the derivative of first, that's L prime times Q plus Q prime times H. L prime, derivative of this, times Q, this, plus, this is product rule, derivative of that, Q prime, times L, the first. And then that equals, when I derive the left side here, I got to also derive the right side, so I get H prime. So from here, remember, I need to solve for Q prime, and I have that right here. The only thing that I don't like about this is that, notice Q is in terms of H's and L's, so I kind of want to have Q prime in terms of H's and L's. If you look here, I got this guy, so he's the one that's kind of blocking me from being able to having only Q prime and then a bunch of H's and L's. Fortunately, I know that that's what Q is, so I can plug that in for this. So that's going to give me L prime times, when I plug Q in, I get H over L plus Q prime times L equals H prime. So from here, what I'm going to do is, I don't like the fractions. I don't want to deal with them. What I mean by that is I got this fraction right here. It just kind of makes everything more work to deal with. So what I'm going to do is multiply by L everywhere. So on both sides, I'm going to multiply by L. And what that's going to give me is, it will give me L prime times H. This L up here cancels with that L down there. Plus Q prime here, I get an L times an L, so I get L squared equals H prime. That guy gets multiplied by an L. So that, I'm going to bring it up here, gives me something for which it has all L's and H's, and a q prime. So I can solve. So I'm going to take this guy and move it over to this side of the equation. That gives me q prime L squared, that's the term that's left over, equals h prime L minus L prime H. Now I'm going to move so we can see the stuff from earlier, like that. So you should see that I'm working my way to this. I'm almost there. This has q prime and a bunch of h's and l's, and I'm almost there. All I gotta do is divide by L squared on both sides, and I get Q, oops, I should make an arrow, Q prime equals, these guys cancel, H prime L minus L prime H over squared, like that. And notice I can rearrange some things. Just switch these two and switch these two, and then what I have in green is exactly what I have there, which is quotient rule, which you can see some examples in other videos of mine, or maybe on some other videos online.